Hi, this is Dale. I'm going to demonstrate some of the even-numbered problems from Chapter 5 for you. So I'll try and keep them in short video segments. So we'll start with problem 5-4 with the manager of the computer store. So you can see that he's been tracking the number of computers sold. And we've got probabilities for selling 0 up to selling 5. So one of the first things I want to show you is that I've listed all the probabilities there. If I go over and just hit the auto sum button, it automatically guesses correctly the range I want, which is great. I'll just click to enter and it adds up to 1. And we know that's consistent, so that entails all of the probabilities, because the probability is going to be somewhere between 0 and 1. That's the range that all the probabilities are limited to. So the first part there, part A, define the experiment as observing the number of computers sold tomorrow, determine the sample space. So the sample space, in this case, we simply would just lay this out with the curly brackets and go 0, comma, space 1, comma, space 2, comma, space 3, and so forth, and close that up. So there's the sample space. It's got to be 0, 1, 2, 3, 4, 5. And then, excuse me, using set notation for the event of selling more than 3 computers, to do that we just put 4 and 5 in there. So again, we wouldn't need to show 3, but we'd need greater than 3. So we just include 4 or 5 there. The probability of selling 5 computers, we just go right over here. We look at 5 and go across, and that gives us the probability of 5. So I'm just going to go equal and put that cell right there, and that gives us that probability. Now I could display these probabilities as percents going up here, and that would be fine. Could do the same down here. Probability of selling at 10%. The probability here in D of selling 2, 3, or 4 computers, so it could be any one of those, would simply be addition. So it would be equal to the probability of 2 plus the probability of 3 plus the probability of 4, for a total, or a probability of 65% of selling 2, 3, or 4. And we don't see probability of 6 listed here, but we know that the probability of selling between 0 and 5 is 100, which means the probability of 6 would be 0. So there'd be no chance of selling 6, because the sample set of 0 to 5 would be 100%. So that's it for 5.4. And why don't I do 5.6 as well? In this case, we've got a department store that's analyzed most of its recent sales and determined the relationship between the way the customer paid for the item and the price category. So we've got the prices listed here in rows 2, 3, and 4, and then whether it was cash, credit card, or debit. And simply those percents are all listed right there on 5.6 on page 76 of your book. I just want to add in totals, both for the rows and the columns. And simply come down here and sum. And then I can grab the fill handle and copy this over. And in this case, I'm going to auto sum across and do the same for these other two cells. And again, we see that we get to a probability of 1, so it includes everything in there. And now we need to answer a few questions. So what portion, A here, what portion of the purchases were paid by debit cards? And we can see right here that that would be 36. Actually, I'm going to move that over just a cell to make this a little easier, so when I post this, it'll make a little more sense. Debit cards, B would be credit card over $100. Again, I'll make that just a little bit bigger. And C will be proportion paid by credit or debit card. And I'm just going to go back here and Alt Enter so it doesn't, oops, I did that twice. Make that a little easier to read and resize that. Alright, so credit card over $100, that portion was actually 23 out of the total of 47. So the simple way to calculate that would be, in this case, go 23 C4 divided by C5, which is going to give you 48.9. Now if you wanted to round that as a percent, you'd go right to 49%. We could do the same, put that in percent, center it. So again, just to get that credit card over 100, it's 23 divided by the total for all credit card to give you the proportion of the credit card that was over 100. And then the proportion paid by credit or debit, and that's simply going to be adding these two together. So the totals for credit plus the total for debit. Again, I can express it as a percent there and center it just to make it look nice, and it comes to 83%. Now you wouldn't have to, I think this chart really helps make it easy to understand it, when you do it, lay it out that way, which the book shows, and then just fill in the totals and you can do the calculations easily. Now you could put in the formulas, and that's fine. But anyway, hopefully that's helpful. So I'm going to stop this video now, and then I'll do 510, 512 on a separate one, probably, and 518 on a separate one. Separate video after that.